So the handout in part 2, a lot of it starts off doing things that we completed in part 1 or day 1. So beginning with our growth factor or B value, so I'd like you to figure out what the B values would be, also called the R value from chapter 1. If you don't remember how to do this, go back to the day 1 handout and look at the notes from that handout. And when you're finished, turn the video back on. All right, so we start off with 100%. It is a growth. So we're going to be adding 8.9%. So we get 108.9%. And then take that number and divide that by 100. So our number, our B value would be 1.089. In problem number 2, we take 100%, subtract 11% from it to get 89%. Then we're going to take 89 divided by 100, so our B value, the second one, is 0.89. Problem 3, again, so the growth, adding 1.5%, so we get 101.5%. Take that number divided by 100, and we end up with 1.015. So basically, for every dollar you invest, you're getting 1.5 pennies profit or growth for each year. And I think each year is at whatever the new dollar amount is. After year 1, you're getting $1.01 pennies for every one of those dollars. And then whatever is at the end of the next year, you're getting $1.01 pennies for every dollar that's in the account that year. The next problem is a decay problem. So we start with 100%. Take away 23%, so that's 77%. Take 77 divided by 100, and we get 0.77. And the last one's a growth, and it ends up being 1.067 is the final answer. Some graphing. I mentioned this in the last handout. I went. Started at 0 and moved up from there. I did spend time graphing to the left of the y-axis. And the reason why is I want you to think about, as you're doing these problems, what should the graph look like to the left or to the right of the y-axis if you were to continue, either if I gave you all negatives or I gave you all positives, and you can come up with what that graph will continue to look like. It doesn't have a long-run value. Does it approach some value as you move to the left or right of that axis? So if you've not completed this graph, go ahead and do that. Plot the points. Think about what happens to the left of the y-axis. Continue that graph onto the left, and you turn the video back on when you're ready to continue. All right, so 2 to the 0 power is 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, and 2 to the 4th power is 16. So in graphing this, 0 the answer is 1, 1 the answer is 2, at 2 the answer is 4, 3 is 8, and 4 is 16. So the graph looks something like this on the right side. It's curved, it's not straight. And then my question is about what happens on the negative side. So if you're looking at the answer going this way, the answers are double. If I go back the other way, basically answers are half as much as they were previously. So that means at -1, the answer is going to be negative, or it's going to be 1/2. And then -2 is going to be 1/4, and then -3 is an 1/8. Again, hopefully supporting this idea about the fact that 2 cubed is 8, so 2 to the -3rd is 1/8. 2 squared was 4, so 2 to the -2 is 1/4. 2 to the first is 2, so 2 to the -1 is 1/2. So again, going back to the 1/2, going into the negative direction for x values, we're taking half of the previous answer. So half of 1 is half of a half is a fourth, half of a fourth is an eighth, and so on. So the graph is getting closer and closer, and the question is, will the graph ever get to the x-axis. So I'll just think about that for a moment. If I continue to take half to get to the next answer as I move left, will the graph ever get to the x-axis? And hopefully you decide the answer is no, because if you take half of an eighth, I get the 16th, half of the 16th, the 32nd. It's going to get smaller and smaller, but there's no way, if I take a half of something, that I'm going to get to 0 unless it's 0 to begin with. So this is what the graph looks like for y equals 2dx. If you would do the same thing for this one, this time I chose negative numbers. And I like to think about what happens when I go to the right side of the x-axis, or sorry, y-axis. So turn the video off, graph it, and turn the video back on. So 0 is 1. 0.5 to negative 1 is 2. Negative 2 is 4. Negative 3 is 8. And negative 4 is 16. So this 0.5 really is 1/2 to the exponent of x. So basically a negative 1 would be, if I turn it into a positive 1, I'm looking at basically 2 over 1 to make the exponent positive 1. And 1/2 to the negative 2 would basically be 2 over 1 squared. So it's going to give me 4 over 1, or 4. So the graph itself actually is negative 4, we're at 16. Negative 3, we're at 8. Then 4. Then 2. And then 1. And so what happens when I go to the positive side, and again, going this way, it's doubling. So if I'm going back the other way, actually each answer is half. So this graph is looking something like this. So the graph, like the previous one, is showing that it's actually a long run value approaching the x-axis but never getting there. This is a perfect example of what we call a decay graph. In other words, as I move to the right, the answers are getting smaller and smaller. Where this one up here is called a growth graph. As I move to the right, the answers are getting larger and larger. So we talked about y equals a times b to the x. This b value, which is always greater than 0, that b value is our multiplier. And when this b value is more than 1, which is here, so it's actually 2 in this problem, we're going to be looking at a growth. When the b value falls between 0 and 1, it's a fraction, then we're going to be looking at some kind of decay because I'm multiplying by a number less than 1, so I'm taking some part of the previous answer. So look at the last two graphs. They are very different in terms of end behaviors as the x value changes. In the first graph, as x increases in value, the y also increases. In the second graph, as x increases in value, the y decreases. So the end behavior or long run value of the function is, in both cases, are approaching the x-axis just on different sides of the y-axis. And the last set of problems that you're going to be asked to do is actually, like I give you two numbers, can you actually figure out the rate of growth or decay? So we did back at the beginning here, I gave you the growth and decay problem and asked you to find the b value. Now what we're going to do is we're going to find the b value first and then turn that into, or define the growth or the decay depending on the numbers. So to calculate that b value, like we did back in chapter 1, we're going to do a ratio. So we take the second number, it's called the b value or the r value, one back to chapter 1. Take the second number divided by the first number. And that's going to tell me my b value or my multiplier. So 102 divided by 120 is 0.85. To turn this into a growth or decay in terms of percent of increase or decrease, what we do is we go back to percent. So we're going to take the 0.85, multiply it by 100, and turn it back into a percent. So 0.85 times 100 is 85, and it's going to be 85%. And the last step is we take that 85% and we're going to subtract 100 from it. So before we start with 100 and we subtracted away our growth and decay to figure out, those are added or subtract away our growth and decay from 100 to figure out what the B value was as a percent. This time we're going to take the B value as a percent and we're going to subtract 100. Take that, whatever that number is, and subtract 100 from it. And so this ends up being negative 15%. It's negative tells me that it's a decay. It's telling me that the answers are going down. And the percent is 15%. So this is a 15% decay problem. So going back up to the previous problems where I was talking about growth and decay, the decay told me that I was 23% below 100. Here, this is telling me that I am 15% below 100. That's what the 85% is. So, 3 more problems. If we go ahead and follow the same steps, kind of look at the numbers. And if you see the numbers are increasing, we're talking about an answer that should be a growth. And if it's decreasing, we should be looking at a decay. When you're finished number 2, turn the video back on. All right, so this time we're going to, again, start with the second answer divided by the first answer. So 69 divided by 60 gives me 1.15. That's my B value, that's my multiplier. I'm going to take that number and I'm going to multiply it by 100 and turn it into a percent. So that's 115%. Take the 115%, subtract 100% away from it, and what I end up with is 15%. So in this problem, because my answer is positive, it's a growth, and hopefully you can see that's a growth because the answer is going up, and it's a growth by 15%. So this is a 15% growth problem, where the previous problem was a 15% decay problem. And again, because this one's 15% above 100, where this one's 15% below 100. Go ahead and finish up the last 2 problems, and then turn the video back on, and when you do, the last 2 problems will be completed for you. All right, so problem number 3, when you divide it, you get 1.25. You turn it into percent by multiplying by 100%, you get 125%. Subtract that from 100, and that will tell you if it's positive, it's a growth by that percent. If it's negative, it's a decay. In this case, you got a positive 25, so you have a 25% growth. And then the last problem, when we do the division problem, you get 0.72, so you multiply by 100% to get 72%. Subtract 72% from 100 to get a negative 28%. So that tells me we have a 28% decay. From here, move on to the mixed master number 7, and that worksheet is due on Friday.